it's seizure or epilepsy, why when you hit fatigue? Because it's running hot. So, well, it is because the weak side is losing so badly, especially because of fatigue, that boom, it decides to just take over, and that's why my job with epilepsy and with seizure disorders is to build this up in opposition to that, and to build it up so hot that it keeps it at bay just by normal activities of daily living. And so that is the genetic structure. So I'm working the other side. But with pseudoepileptic form disorder, I have damage or cells that are dying, and they are trying to save their own life. And in this case, I'm working directly on those cells rather than on their opposing cells on the other side. So I'm building them up and helping them go from transneural degeneration, TND, to plastic. We're making them plastic over time so that they won't go rogue anymore. They're going rogue because they're dying. The cell only becomes plastic or maintains plasticity by firing. You need oxygen, you need carbs, and you need activation. But you need protein to activate. That's why I'm still going to say activate, because you could have protein and no activation, it's going to die. It doesn't have a choice. And so what I'm doing then is, as it gets less and less activation, if you don't use it, you lose it, right? And so you wind up with cellular junk that doesn't get jettisoned and doesn't get replaced. So we're getting fewer and fewer mitochondria. We're getting stuff. If you've taken biology and you look under a microscope, you'll notice that the nucleus is dead center. And one of the things that's the death knell of a cell is when it moves away from center. Well, you've got this skeletal architecture, microfilaments that are holding it in its place, so that it maximizes the surface to volume ratio, so that you can get things in any direction, and the nucleus gets the benefit of all of it. Well, as those microfilaments start to break down and don't get replaced, the nucleus moves away from the center, and it's going to die, right? Well, we're trying to take those cells. They've become hypersensitive just to save their own life. You would think that, it's not going to fire. No, it will fire much easier, and it will take neurotransmitters that normally it doesn't need, right, or won't respond to. And it'll go ahead and respond to even cellular junk, toxins, whatever, in order to save its own life. And so it fires so that it can go through immediate early gene response and start replacing some things. But what's the difference between it and a healthy cell? Fatigability, right? Maybe I can fire it 3, 4, 5, boom, it's done. And so we have to keep it within its metabolic capabilities. Is everybody gone? Okay. We got to keep it, we got to work with it, but within its metabolic capabilities, because we could hit it too hard and it dies, because it can't keep up. And so that's the TND side of the problem. That's the pseudoepileptiform part of the problem. So, and it's really common with traumatic brain injuries, with other reasons for, that injury causes cells to be sick and dying, and that could be stroke, could be sitting next to a tumor, it could be, so many different things. But that's why I have to know, is this running hot or cold? Because if I take a hot side and I beef it up, it makes it worse.
Yes, it does.
You felt it today.
Yes.
Right? And so I've got, and if it's a series of 6 cells, if I'm working with it, but let's say I work the opposite, like I would normally do with a seizure disorder or epilepsy, I'm going to make it worse. because I'm going to squash the DMD, which makes things worse.
One thing that all my neurologists before have said, you have non-epileptic seizure disorder, which is pseudo-psycho, pseudo-epileptic seizure. They didn't call it that. They called it pseudo-something. And they said, you're just making it up in your head. You are creating these seizures because you're upset and you're making it happen. And I'm like, well, that doesn't correspond, because when I truly am upset, I don't get a seizure.
Right.
But then just when I'm sitting there, all of a sudden I'll get a seizure.
No, you see, I think that's a severe lack of understanding of what the problem really is, because could you getting upset bring one on? Yeah, but what is it doing? It's fatiguing the system. It always goes back to fatigue, whether it's epilepsy, seizure disorder, pseudo-epilepsy, it always goes back to seizure. It goes back to fatigability. Whatever caused that fatigability, and they say, well, I really wasn't that fatigued. Say, the parts that are the weakest went below their threshold. They couldn't handle it, right? It's not all the strong parts of your brain that are having the problem. It's the weak parts. And when you have enough fatigability that those weak areas now are triggered, it's going to happen, right? And in 100% of the cases I've taken care of, in 100% of their triggered events, I've always been able to bring it back to some kind of fatigability.
They want to medicate me for mood disorder or depression or manic depression or bipolar. That was the first go-to with all the doctors.
And why is that?
Because you're bipolar and you're manic depressive and you're making all this happen in your own brain.
When all you got is a hammer, every problem looks like a nail. And when all you've got is a screwdriver, somebody's getting screwed, right? These are guys that are all taught the same way, by the same teachers, by the same books. And I hear all the time, well, it's a different book. I said, yeah, but they plagiarize each other. It's saying the same thing. And people ask me, who should I see? And I said, pick one, they're all the same. Yeah, but I'm seeing this really super specialist. I said, yeah, but he's trained the exact same way. He's just a little more accurate with how he doesn't know how to do what he's doing. And so when we're looking at it, we're saying, where are the cells and how are they going wrong? Because what I say in here over and over again, and you saw it on my whiteboard, the closer you get to the truth, the simpler the solution. And we want to know where it is. It's like my patient that has, a seizure disorder in Brokaw's area, left side speech, right, the motor speech area. When it's kicking up, she can't talk. It's like slamming the brakes on. And when I work 44 and 45 on this side, all of a sudden it lets up the brake and she can talk. And you could think, well, maybe that's another issue in terms of basal ganglia, brake pedal. Yes, it is, right? It's a part of the problem. And you say, well, maybe it's problems area 9, 11, and 12. Yes, absolutely. Now we're getting somewhere. And we're also getting to the solution. We're gonna have to build those circuitries up so that just by being up, just by being awake, just by being alert, that circuitry is running so high that it's inhibiting those ones that tend to like to express when we don't want them to. That makes sense?
Yes. So what are the drugs doing when you shouldn't be taking the mood altering drugs for this pseudo seizure disorder?
Unless you have a true issue.
That is not the issue
That
to be put on
you
there.
had it before, right? You had it before because it potentially could drag the system down. I get that, severe depression, severe anxieties, and that all of those things can create fatigue fast, right? And if that's the case, let's dial it down. I want to figure out why, and I want to solve the why for those things. Because if I just treat the what, I'll be treating it forever. Oh wait, that's a practice management thing, right? Yeah. No, we want to find the why, change the why, and the what goes away. And so, but in the interim, I got no problem with, let's use that to dial it down while we're fixing that part that's causing the seizure disorder, but also why are we having this severe anxiety, this severe depression, and that, and then working with that so that there's less and less need for the medication.
Right. That's good.